So for any real number k, any exponent, real number exponent k, we can find the derivative by bringing down that original exponent to the front. I'll bring that down first. And the original exponent will go down by 1. So instead of saying k, you will have to raise that to k minus 1 power. Okay, so I'm going to give you a whole bunch of examples. So bring down the original exponent, go down by 1. That's the power rule. So if you look at this one, y equals x to the 15th power. The derivative will be, you bring down that 15 to the front, or you go down 1 on the exponent. So 14. So that's it. B, well, there's no exponent here, right? But if it's just x, is x being raised to the first power. So let's apply the same rule. You bring down that exponent of 1 to the front, but you need to go down 1 from 1. So you have x to the 0 power. But what is anything to the 0 power? And that's not 0. Anything to the 0 power is just 1. So if you do 1 times 1, you get, oh, whoopsie, I forgot the derivative symbol. Y prime comes out to be 1. Okay? Well, let's look at this one. Well, we still need to bring down that exponent of -4 to the front. If you bring that down, y prime is going to be -4x, but the exponent has to be 1 smaller than -4, and that is -5. Okay, so those were A, B, C. Let's look at the ones that are a little bit trickier down here. So D, it's not written in exponent form. So you will have to rewrite this first. Anytime you see an expression that is not in an exponent form, rewrite it. You can write this as y equals x to the 1/5 power, because that's what fifth rooting is, raising it to the 1/5 power. So let's bring down that exponent of 1/5 to the front. But the exponent has to be 1/5 minus 1. So you need to do 1/5 minus 1, which is 1/5 minus 5/5. And if you subtract, you get -4/5. And that should be the new exponent of the derivative, okay? So this one was a little bit tricky. Whenever you have a root expression, rewrite it so that it's in the exponent form, and you apply the power rule the same way, okay? But you may have to subtract some fractions in case the exponent is a fraction, okay? All right, let's do this one. Bring down that original exponent of 0.7 to the front. So the derivative is 0.7 x to the, well, now for the new exponent, you have to do 0.7 minus 1. If you take away 1 from 0.7, you will get -0.3. Okay? All right, D. Oh, it's a little bit different, huh? Now, I forgot to, well, I didn't give you the second theorem over here, that derivative of a constant function. So, for example, if I ask you to find the derivative of a number, like 5, that's going to be automatically 0, okay? And here's the reason, okay? Think of C as C times x raised to the 0th power, okay? See, there's no x here, right? When there's no x, you can think of there is hidden x to the 0 power. So if you apply the rule, okay, if you do the same power rule over here, what exponent do you have to bring down? 0, right? So you have to do 0 times c. And 0 times c will give you 0. And the exponent needs to go down by 1. And 0 minus 1 is negative 1, but it doesn't matter because anything times 0 is just 0. So there's a reason behind it, but anytime you see a constant like this, y equals 2, the derivative is automatically 0. Down here, I gave you pi squared. Well, that's like 3.14 blah 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 squared, right? You notice this is a constant. This is a constant. It's just a number. So derivative of any number is always equal to what number? 0. When there is no x and you're taking the derivative, it's just going to be 0. Okay? All right, let's see. Let's do 2 more on this page, and that will be it for this page. Rewrite this into a form that has an exponent. Square root of x is the same thing as x to the 1/2 power. Okay? Bring down that exponent of half to the front and go down 1 from half. So if you go down 1 from half, that's half minus 2 over 2. The new exponent will be negative 1/2. Okay? All right, last one. Y equals 7x. I don't see an exponent, so I may just put a 1 for the x's hidden exponent. So the derivative will be, I need to bring down this 1 to the front. But look, when it comes down, it's going to meet that 7. So I will now need to do 7 times 1. And 7 times 1 is just 7, right? And x, the new exponent will go down to 0. But again, anything to the 0th power is 1. Whoopsie, where did that go? Anything to the 0th power is just 1. So this just becomes 7 times what? 7 times 1. So the answer is 7. So I'm like making this long and long and long, but I mean, hopefully, like if you see the pattern here, like let's say y equals 14x. The derivative of this will just be 14, okay? If you see y equals 25x, I'm just making stuff up, then y prime is equal to what? Just 25. If it's a linear function, the derivative will just be that leading coefficient. Okay, so you can you'll see a whole bunch of patterns as you do more problems using power rule.